So let's talk about the first question. They are talking about polynomials. The polynomial function p is given by negative 4x raised to 5 plus 3x squared plus 1, and which of the following statements about the end behavior of p is true? So without even reading the questions, we have a very straightforward rule that if the degree of the polynomial is odd and the leading coefficient LC, if that's negative, then more negative we go in the x-axis, of course, the more negative we go, this term will keep on becoming positive because that's an odd power, right? So negative just pretty much comes out, and that negative is multiplied with the negative leading coefficient and becomes positive. Please keep in mind that in any polynomial any polynomial's end behavior, only the leading term plays a role. The other terms can just be ignored. So more negative it goes, x goes towards the negative side, then y value increases, and x goes towards the positive side, then exactly opposite, y value decreases. So can we say that limit x approaching towards negative infinity is positive infinity, which is in option number 1 and option number 2, and limit x approaching towards positive infinity is negative infinity, which is in option number B. And let's read the complete option. Says that the sign of a leading term is negative, of course, and the degree of the leading term of p is odd, of course. So the definitely what we are saying is absolutely correct. So the correct choice is option B, if it makes sense. Yeah. All right, so no calculators allowed, of course, please keep that in mind. The second question is the depth of water in feet at a certain pace in a lake is modeled by this particular function w, which is shown to us. So this is the depth of water at a certain place in a lake. So this is the, okay, this is the time, they just say it here, for t from 0 to 30, where t is the number, sorry, t is the, yeah, I mean it's time, but this is in days. So number of days since the first day of the month. So this is the third day, sixth day, and that month, particular month is of 30 days. So these are the days and these are the depth of the lake. What are all the intervals of t where the depth of the water is increasing at a decreasing rate? So be careful, increasing at a decreasing rate. So first we will isolate all the intervals where the depth of the water is increasing. So obviously it is increasing from here to here, then it's decreasing, and then it's increasing from here to here. But when they say that the rate of increase, that it is increasing at a decreasing rate, it means that they are looking for a concave down function, because concave down is the function where the way the rate is changing is actually at a decreasing rate. So if the rate is decreasing, it is concave up, concave down, and if the rate is increasing, it is concave up. And what is concave down? It's basically a frowning face. You know, a frowning face is concave down. Even a part of it, it's concave down. Clearly, it is not this one, because this is a smiling face, right? Smiling face is concave up, concave up, concave up, and frowning face is concave down, concave down. So obviously, it is not this portion because that is concave up. Now here there are two portions if you look carefully. 3 onwards it's a frowning face, but 0 to 3 is a smiling face. So the answer should be 3 to 6, because from 3 to 6 we can clearly see that this is a frowning face, and frowning face is concave down, and that's what we want. So the answer is going to be option A, which is 3 to 6 only. That was a really good question. I hope that makes sense. All right, okay. Now let's talk about this one. Which of the following functions has a 0 at 3 and has a graph in the xy plane with a vertical asymptote of 2 and whole of negative 1? Sorry, whole of x equal to 1. So first things first, if it has a 0 at x equal to 3, it means that it must have a factor of x minus 3. And since all the options are rational functions, we must conclude that x minus 3 must be present at the top. Of course, I don't see any x minus 3, I do see x minus 3 here, but it doesn't mean that x minus 3 cannot be here, because these are not factored. So we have to keep that in mind. We cannot just rule out a and b just because we don't see any x minus 3 explicitly. Okay, all right. If you want to factorize option A, the numerator, it will look like x minus 1 times x minus 3, and indeed I have an x minus 3. And if you want to factorize this one, it will be x minus 2 times x minus 3, and indeed there is an x minus 3 over here. So unfortunately, just based on the root, I cannot rule out any of the option. But the moment I see that there is a vertical asymptote of x equal to 2, this means that this vertical asymptote should be in the denominator and denominator only. Because the property of being a vertical asymptote is that should have a degree, that factor should have a degree more than the same factor in the numerator. So either the numerator should not have it entirely, or even if it has, it should have a lower degree. Okay. Now let's see which options first off have an x minus 2 at the bottom. So if we were to factorize this will become like x minus 1, x minus 3, and clearly this cannot be the answer, because x minus 1, x minus 3 does not have x minus 2 anywhere, and at least I need an x minus 2 at the bottom. So this is not possible. Can it be this x minus 1 times x minus 2? Yes, it can be this, because there is an x minus 2 at the bottom and the numerator does not have any x minus 2. So it is a vertical asymptote. Likewise, this is x minus 1 times x minus 2 now. This is interesting. Although it has an x minus 2, but remember that there is an x minus 2 also on the top, which negates the very definition of vertical asymptote, because even if that factor is in both the denominator and the numerator, over in the denominator it should have a higher degree, but clearly it's not a higher degree. So x minus 2 is or x equal to 2 is not a vertical asymptote in B. And finally here I have x minus 1 times x minus 2 over here, which is also a vertical asymptote at x equal to 2. So probable options are A and C. And finally, it has a whole at x equal to 1, which means that x minus 1 is a common factor of top as well as the bottom. That's the only way. Or x minus 1 at the top should have a greater degree. But we don't have to go till the greater degree, because here we can clearly see that x minus 1 is a common factor on top and bottom. And in option C is just x minus 3. X minus 1 is not a common factor in the numerator and denominator. So clearly, by all this logic, the correct option is option number A. It was a little tricky, but I hope it makes sense. All right, let's talk about the next question. This one says that the polynomial function p is an odd function and p3 is -4 is a relative maxima of p. Which of the following statements about p of -3 must be true? Okay. The first things first, odd function is symmetric about the origin. Odd function is symmetric about the origin. How does that help us? Try to visualize this graph. This is, let's say, our coordinate axis. And it's already given to us that p of 3 is -4. So p of 3 is -4 means this is 3 and this is -4. So p of 3 is -4 is somewhere over here, and this is a relative maximum of p. It means that the graph over here should have been like this, because that is the only way, that can be that can behave as a maxima. I don't really care about how the graph goes over here or over here. I just care that about 3, if it is a maxima, then obviously it should just have a jump at that point. And now this is symmetric about origin. And how to draw a function which is symmetric about origin? We flip it around x-axis and y-axis both in any order. So let's say I flip this about y-axis, so it will look like this. And obviously when I flip around y-axis, this point will become -3. And when I flip around x-axis, this will become like this. And clearly this means that obviously this is -4, so flipping will make this as 4. So clearly, first off, this is a local minima, so the maxima options are just ruled out. It's just a local minima. And we know that now P of -3 is clearly 4. P of -3 is 4, which means that option C is the correct choice. This was also a little challenging, but I hope this one makes sense. All right, the last question which we have for this video is the function g is given by gx is a cubic function, and the function h is given by quadratic function, and k is a function which is this. So what is the domain of k? This is a very straightforward question, because k is a rational function, right? It's just a ratio of the polynomials. H is a quadratic, which is x squared minus 2x minus 35, and the g is x cubed minus 3x squared minus 18x. And remember that for the domain of the rational functions, it's the only condition is that this guy should not be allowed to be 0, because if it is 0, it's just undefined. We cannot have a 0 in the denominator. So we will find those values which are making it 0, and then we will just exclude it. That's what we are going to do. So our aim is to find that at which values x cubed minus 3x squared minus 18x is actually equal to 0. That's our aim over here. So if we want to do that, we are going to have I believe x is taken as a common factor, so we are left with x squared minus 3x minus 18 is equal to 0. Let me separate my work right here. Okay, so this means that x times, and this quadratic can easily be factorized, right? I think that's going to look like x minus 6 times x plus 3 is equal to 0. It is a zero product property, which means that x is equal to 0, x is equal to 6, and x is equal to minus 3. So these are the 3 values of x which are not allowed. So it means that all the real numbers are allowed except -3, 0, and 6. Clearly they have written not equal to over here. So option C is the best choice for us, if it makes sense. So this question says that the figure shown in the graph of the polynomial g is of a polynomial function g, then which of the following could be the expression for g? The first thing which we can notice with all the options is they are in factored form. And the first and foremost, in fact, the crack which we can develop is noticing the roots. I can surely see that there are two positive roots, and there is surely one negative root of this particular polynomial function, which means that there will be, if we analyze the options, option B is just not possible, because it has x plus 5 equal to 0. This expression equal to 0 would mean that -5 and -1 are the two roots which are just not possible, because these two are negative, but there are no two negative roots, there is only one. So B is not possible. And likewise D is also not possible, because there are two negative roots over here. So it has to be either A or C. Now the only difference between A and C is the multiplicity of x minus 5. In one of them, the multiplicity is even, and in option C it's even, and in option A it is odd. But since we notice here that the function bounces back to its original position, which means that the multiplicity at that point must be even, because that is the only situation when the function can just bounce back from this point. So if it bounces back, this would mean that it has an even multiplicity, which means that the correct option is option C over here. Yeah, I hope that makes sense. Let's talk about the next question. Question 7 says that the table gives values for a polynomial function f at selected values of x. So there are some selected values of x, and the polynomial functions are values are given. Let g be a times f of bx plus c, where a, b, c are positive constants. Okay. In the function in the xy plane, the graph of g is constructed by applying 3 transformations to the graph of f in this order: a horizontal dilation by a factor of 2, a vertical dilation by a factor of 3, and a vertical translation by 5 units. So what is the value of g of -4? So in other words, we need to determine what is the value of a, b, and c in order to determine the value of the value of g of -4. Right, so as soon as we know that the function g of x is a times f of bx plus c, we do the activities of the transformations one by one. So first we look for what is the function gx when translated by with a horizontal dilation of a factor of 2. So as soon as there is a horizontal dilation, this is going to look like f of x over 2, because that's the horizontal dilation of 2. Then they talk about the vertical dilation by a factor of 3. It means that it is just 3 times of it, so we just multiply 3. And finally there is a vertical translation of 5, which means that you just add 5 to it. If you're wondering that it can be vertically translation down as well, so notice carefully that they have already mentioned that all of them are positive, so there's no confusion about that. All you have to do now is replace x with -4, because as soon as we do that, this is how it's going to look like. And let me separate my work over here. So this is going to look like, all right, so g of -4 is now going to be equal to 3 times f of -2 plus 5. And what is the value of f of -2? It's from here, f of -2. At -2 the value is 5, so it is 5 over here. 5 times 3 is 15, and 15 plus 5 is 20, which is option D. That's our final answer. Yeah, hope this one makes sense. Yeah, that's correct. Okay, so the next question we are going to talk about log. So this is, I think, pretty straightforward as in we just have to make sure that we know a couple of properties of the log before answering this question. So they want the equivalent form of this thing. Okay, the first things first, we are given log of a over b. Log of a over b. So this is going to look like log of a, as in the numerator, minus log of b, which is the denominator. So this is going to look like, what is log of a times b? Log of a times b is log a plus log b. So this is going to look like a log of a plus log of b minus log of this thing. And finally we have another property. I'm just writing the first two things as it is. And then we have a property of the log, that if you have a log of something which is raised to a power, then that power essentially just drop outside and sits as a coefficient. So this 2 is going to drop outside, and it's going to look like 2 times log of w with base of 10. So this is our final answer. This is our final answer. And if you look at the options, I think log of k plus log of z minus, that's option B, correct? Yeah, correct. That's option B, that's matching. So I hope this one makes sense. Let's talk about question number 9. I'm just going to put my mobile phone on silent. Okay. Yeah. The values of the terms of a geometric sequence Gn are graphed over here. So which of the following is expressed is an expression for the nth term of the geometric sequence. So for the nth term of the geometric sequence, I would be needing the first term and the common ratio. Correct? Okay. There are two ways to solve this. Either we can reverse engineer and plug in the value of n as 2, for instance. It should give us, in fact, n as 1, for instance. So it should give us the value as 8. So we just plug in n as 1 and see which one is giving us 8. And that ways we can just keep plugging in, ruling out options, and we can figure that out. So I will show first using this method. If n is 1, then this will become 8 times 1 over 2, which is just 4, but I need 8, so this is not correct. If n is 1 over here, then 1 minus 1 will become 0. 1 over 2 raised to 0 is just 1, which is just 16. So this is also not possible. If I put 1 over here, then this will become 8 times 2 raised to 1 minus 1, which is again 2 raised to 0, which is again 2 raised to 0 is 1, which is again 8. So this is possible. And if I put 1 over here, actually that is also possible, because this will become 4 times 1 over 2 raised to minus 1, which is 4 times 2, which is just 8 over here. So this is also possible. So we have ruled out two options from here. And then let's try to put n as 2 and see which one is giving us 4. This will definitely not give us 4, because if you put n as 2, it will become 2 minus 1, which is 1, and 8 times 2 is just 16. In fact, we could have ruled out with an even more smart way, because you can see that the terms are decreasing, which means that the common ratio is less than 1. So clearly, this is the only one which is less than 1. It cannot be greater than 1. So B is also ruled out, and the correct option is option A. That's one way. Another way, if you want to do the traditional way, is, of course, so you know the value of A1 already. It's given as 8. You know the value of A2 is given as 4. So the common ratio will be A2 over A1, which will be 4 over 8, which is just 1/2. So we got the common ratio, we got the first term, and it's very easy to write the nth term now. So the nth term is going to look like, the nth term is going to be A sub n is equal to A1 times r raised to n minus 1. It's 8 times 1 over 2 raised to n minus 1, which is obviously not anywhere in the options. So this can be rewritten as, 8 can be written as 4 times 2. So it will be 4 times 2 times 1 over 2 raised to n minus 1, which can be written as 4 times 2 raised to, or just 2, and 2 raised to 1 minus n, just powers are swapped. This will become 4 times 2 raised to 2 minus n, because the powers are being added now. And this can now be written as 1 over 2 raised to n minus 2. Because as per the rules of exponents, we take the reciprocal of it, and the power is just negative now. So this is the conventional method. If you feel conventional method is pretty straightforward, go for it. Otherwise, you already know what the other method is. So both ways, you know the answer. All right, okay, let's talk about the last question for this video. Looks pretty straightforward. The table gives the value of the function g for the selected value of x, and there is another function fx which is given by this. So we need to find the value of the nested function or the composite function f of g of 3. Okay. What is g of 3? The value of g at x equal to 3. Where is x equal to 3? Right here. What is the value of g corresponding? Negative 2. So can we agree that the value of g of 3 is negative 2? This means that f of g of 3 will be f of negative 2, because g of 3 is negative 2. So I just replaced this guy with negative 2. And what is f of negative 2? We already know what f of x is. All we need to do is replace x with negative 2. So it's going to look like 3 raised to negative 2. This x is replaced with negative 2. And then this base x is also replaced with negative 2. So that's negative 2 whole square. So it's going to look like 3 raised to negative 2 is 1 over 9. I hope you understand. It's nothing but 1 over 3 square if I were to add another step. And negative 2 square is just 4. 1 over 3 square is just 9. So 1 over 9 plus 4. And 1 over 9 plus 4 is just, 9 times 4 is 36. 36 plus 1 is 37. It's 37 over 9 because I've just taken I just made a common denominator and just added both of them. So the correct answer, correct option should be option B. Food vendor developed a new sandwich type for sale. The vendor made estimations about the sales of the new sandwich type over time. A linear regression was used to develop a model for the sales over time, and the figure shows a graph of the residuals of the linear regressions. Which of the following statement about the linear regression is true? Alright, okay. The linear model is not appropriate because there is a clear pattern in the graph of the residuals. The linear model is not appropriate because the graph of the residual has more points above 0 than below 0. The linear model is appropriate because there is a clear path in the graph of the residuals, and the linear model is appropriate because the positive residual farthest from the 0 here and the negative residual farthest from the 0 are about the same distance. All the more points are above 0 than below. Well, residuals are sort of like the error, right? And don't you think the errors are actually forming a quadratic pattern? It's a parabola, right? So it means that the linear model is actually not appropriate because the residuals are clearly showing us a particular pattern. Option A is the most relevant option because of the pattern shown by the residuals. Yeah, this is pretty much like theoretical or conceptual. The next one, they're talking about the value in millions of dollars of transactions processed by an online payment platform is modeled by the function M. The value is expected to increase by 6.1% each quarter of a year. Okay, all right. At the time t equal to 0, there were $54 million of transactions were processed. And if t is measured in years, then which of the following is an expression for mt? Okay, so basically what they are saying is at t equal to 0, the processing amount was 54 million, and it increases by 6.1% every quarter. Every quarter, not every year. What this means is, if you put the value of t, it's very clearly given that a quarter is 1/4 of a year. If you put the value of time as 1/4 a quarter, the increase will come out as what will be the factor? 6.1% is the increase. So the factor increase, it will increase with a factor of 1 plus 6.1 over 100, or 1 plus 6.1 percentage, which is going to be 1 plus 0.061, which is going to be 1.061. It means that if you put t as 1/4, the multiplication factor should come as 1.061. And this you can clearly see that if you put 1/4 over here, this will surely become 1, but this is 0.061, which is not what I need. But if you put t as 1/4 over here, this will come as 1.061, which is exactly what we are looking for. So option D is the correct choice. These two are just not possible anyway because of 0.061, and it cannot be t/4, because if we put, if the expression has a t/4, and if we put t as 1/4, this will become 1/16. This will become 54 times 1.061 raised to 1/16, which doesn't really make any sense because I only need this. I don't need it with the power of 1/16. So option D is the best choice indeed. Yeah, hope that makes sense. Let's talk about this one. Iodine 131 has a half-life of 8 days in a particular sample. The amount of iodine 131 remaining after D days can be modeled by the function H given by this. So this is the amount of iodine which is left, where A naught is the amount of iodine at the in the sample at t equal to 0. So A naught is the the iodine sample with which they started, the amount. Now, which of the following functions K models the amount of iodine remaining after 3 hours, where A naught is the amount of iodine 131 in the sample at t equal to 0. There are 24 hours in a day, so t is equal to 24t. Okay. I think what they are asking over here is just the conversion, because they have already given us the value of h of d, where d is in number of days, and this is obviously giving us the amount of iodine remaining after d days, and what they need from us is the amount of iodine remaining after t hours. So all we have to do is convert the days into hours, and we know that t is 24d, that's clearly given to us, so the number of days are going to be t over 24. So all we have to do is replace d with t over 24 over here. So this is going to look like h of d will be equal to a naught 0.5 raised to d over 8. So d over 8 can be written as 1 over 8 times d, and this d can be written as t over 24, right? What is 24 times 8? 24 times 8 times 4 is 32. This is 3. 8 times 2 is 16, 17, 18, 19. So this is 192. So this will come out as a naught times 0.5 raised to t over 192. This will be the equivalent expression for the same thing in t in terms of hours, which is option D. It was pretty straightforward. They were just trying to confuse us with the complicated language, I would say, but otherwise that was pretty straightforward. Right, okay. Let's see this question. So it's given that what are all the values of x for which ln of x cube minus ln of x is 4. Pretty straightforward. We just have to use one simple property of log, that whenever you have log of something raised to a power, then that power will drop outside like this. So this is going to look like excuse me, 3 ln of x minus ln of x is equal to 4. 3 ln x minus ln x is 2 ln of x, that is equal to 4, which means that you're going to divide both sides by 2, so ln of x will just be 2. Let me just separate my work over here. So if ln of x is 2, what will be the value of x? You just pretty much take an anti-log both the sides. So how do we take that anti-log? How do we isolate x? Just to apprise you, if I have log of a with base b is equal to some constant k, and if you want to isolate this b, so this b remains as it is, this a is thrown over on the other side in such a way that this k comes to its power. This is how we isolate b. And likewise, since this is a natural log, and if it helps you understand this even better, although we don't really write like this, like log of base e is equal to 2. We don't write like this, but just to make you understand, here the base is e and we need to find x. So based on the blue thing, x remains here, e is thrown over on the other side such that this 2 raises in its power. So the value of x is e square, which is, I think, only option C, correct? Yeah, that's the only answer. Makes sense, right? Okay, let's move on to the last question which we have here. Okay, Let the function be this and fx be this, gx be this in the xy plane. What are the x coordinates of the points of intersection of f of g? Okay, so points of intersection basically means that where are the two functions equal, right? So in other words, they are looking for the values of x where these two will be equal to each other. The function is 1 plus 3 sec x and gx is nothing but -5. I'm going to subtract 1 both the sides, so it's going to look like 3 sec of x is -6. I'm going to divide both sides with 3, so sec of x is -2 because 3 times 2 is 6. If you're obviously not comfortable with sec, totally fine, convert that into cos, because cos of x will be nothing but -1/2 as sec is 1/cos, so I just took the reciprocal on both the sides. If you are having trouble understanding this, I'll write one more step. Sec is 1/cos as per the reciprocal identity, and then taking reciprocal both the sides, cos is -1/2. And when is cos -1/2? In quadrant 2 as well as 3, because in 1 and 4 cos is positive. And what is the reference angle? The reference angle we can just find by dropping the negative sign. So the reference angle is going to look like cos of x is equal to 1/2, which means that x is 60 degree, right? Pi/3. That's the reference angle. But I need the answer in quadrant 2. So that's going to look like pi minus pi/3, which is in quadrant 2, and pi plus pi/3, which is in quadrant 3. So this is going to look like 2 pi/3 and 4 pi/3. So it's 2 pi/3 and 4 pi/3. That is the answer, which is option number C. The figure shows the graph of a sinusoidal function g. So what are the values of the period and the amplitude of g? Amplitude is really easy to find, because first we need to find the midline, and midline is nothing but the middle value of the maximum and minimum. So the maximum value is 3. The minimum value is obviously -3, so its middle value will be 0, which is right over here. And from the middle value, whatever it goes to the top or whatever it goes to the bottom, that number is the amplitude. So from middle, it goes 3 units up, because this is 3. So the amplitude is 3, which means that these two are incorrect. The last two are ruled out. And the time period is the time which is taken for one complete cycle. You can start the cycle from anywhere which you like, but make sure that obviously you complete at the same point. For example, let's say I start from here. So my one cycle will look like goes here, goes here, down, 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 and this. Because after 9, it will again start repeating itself. So that can be my cycle. So what is the value of x here? You can clearly see that it starts from 1 and it ends at 9. So it's 9 minus 1, which is 8 units is a time period. Or another way to find the time period would be, let's say you start from the top. You don't want to start from the bottom. You start from the top. So you start from the top, goes down, and then go up, and you stop right there. So once again, you have over here is 3, and over here it's 11. 11 minus 3 is once again 9. So it doesn't really 11 minus 3 is 8. So once again, it doesn't really matter how you do that. You will keep on getting the same answer. It doesn't matter from excuse me, from where you start and where you end, provided you complete that one complete cycle. So that's going to be equal to 8, and the amplitude is 3. So the correct choice is option B. Correct, it is B. All right. Oh wow, this is an interesting one. It's based on the polar equation, that which is the following graph of the is the graph of 3 cos theta plus 2 in the polar form. So let me write the equation separately. If theta is 3 cos theta plus 2, I'll tell you a really easy way which works pretty well with the options to rule them out and to find the answer for especially such polar coordinate. Find the range of R. Find range. What do I mean by the range of R? Range of R means that find the maximum value and the minimum value of R. Maximum value of R, because f theta is nothing but R, right? R is equal to 3 cos theta plus 2. The maximum value of R is going to be when cos is maximum, and cos is maximum when it is 1. So the maximum value will become 3 times 1 plus 2, which is 5. The minimum value of R, in fact, remember that we are always looking for the minimum value of absolute value and maximum value of the absolute value. So if we talk about the minimum value of R, that will be when cos is -1. So this will be 3 times -1 plus 2, which is -1. But since I'm looking for the minimum value of absolute value of R, obviously the minimum value of absolute value of R will just be 0, because it cannot be -1. So the minimum of absolute value must be 0. Just, this is a really important concept. In fact, you should know it if you don't know it already, that finding the absolute value of R gives you actually the minimum distance from the center or the pole, and the maximum distance from the center to which your graph can go. And if your R minimum is coming negative, then absolute value of R minimum is just 0. It's kind of a eventually you have to just learn that this is how it works. Now, if we know the minimum value of R and maximum value of R, I know that my graph must cross the origin, because at origin or the pole only, the minimum value is just 0. And clearly all 4 of them are crossing the pole, so all 4 can be the answer, at least with this thing. But the maximum value of R from the center can be 5, not more than that. It cannot be less than that as well. So you can clearly see that this is only 4, this is only 4, these are only 4. It cannot be the answer, because we just said that the maximum value of R should be 5. So A and B are not possible. Here clearly we have a 5, and here clearly we have a 5 as well. So this can be the answer. All right, this can be the answer. Now, another major difference between these two is, here the value of R equal to 1 is possible, somewhere at theta equal to, because here the value of R is coming 0 to be at 2 instances, like it is 0 for some value of theta, and then it is again looping back, and then again it is coming as theta equal to 0. So how can we figure that out, whether that's C or D? So we're going to need some more work over here. Let me clear this up. Okay. If I put theta equal to pi over 2, at pi over 2, what is the value of cos pi over 2? That's 0. So this will become 0, and this will become 2 over here. So this means that R is equal to 2. Indeed. Okay. If theta is equal to pi, then the value of R will become cos pi is just -1. So this will become -1 over here. Okay. And if theta is equal to 3 pi over 2, once again the value of R will become 2, because cos of 3 pi over 2 is 0. So it's just 1 over, it's just 0 plus 2, which is just 2. Okay. Now, what does that mean? What does that mean? If I am at pi over 2, my value is 2, which is clearly 2 over here as well, and 2 over here as well. If I'm at 3 pi over 2, I'm still at 2, which is 2 here and 2 here as well. But if I'm at pi, my value is -1. So absolute value of R is 1. But here you can clearly see that if you are at pi, because pi is just like a horizontal line, it is either 0 or 5, which is not correct. Because at pi it is 1, absolute value is 1 as well, because its distance from the pole is 1, which clearly is in option D. Its distance from the center is 1. Hence the correct choice is option D. It was a tricky one, I know, but yeah, this is how we solve it. Makes sense, right? Let's talk about this one. What are the values of theta for which 2 cos theta is greater than -1 and 2 sin theta is greater than √3? I think it's a good idea if we can rule these out from options one by one. Uh, let's talk about this thing. This looks at least relatively easy to deduce, that 2 sine theta should be greater than √3, which means that sine theta should be greater than √3/2 from -pi to pi. Well, if you ask me, I'll just draw a graph, because making a graph will be really helpful for us. -pi to pi, sine is going to look like this. This is pi, this is -pi, and they need it to be greater than √3/2. And can you tell me where is sine, at which angle is sine √3/2? 60 degree. First angle is 60, which means that 60 is somewhere around this, pi over 3, because this is pi over 2. And another angle at which it is √3/2 is in quadrant 2. And the quadrant 2 angle is pi minus pi over 3, which is 2 pi over 3. And 2 pi over 3 is right here. We want that to be greater than √3/2, which definitely means that we want it to be this. We want it to be this, because this is the region where it is greater than √3/2. So our answer is pi over 3 to 2 pi over 3. Correct? Pi over 3 to 2 pi over 3. So anything which is not here cannot be the answer. Obviously, this is not getting satisfied. Pi over 6 onwards cannot be satisfied. -2/3 cannot satisfy. It has to be option D. Even without seeing the 2 cos theta is greater than -1 option or solving that inequality, I know for a fact that it should be option D, because that is the only one which is satisfying 2 sine theta is greater than √3. Yeah. But just for the sake of clarifying, I'll solve 2 cos theta is greater than -1 as well. Again, I'm going to do the same thing. Cos theta is greater than -1/2. So I'm just going to make sure that in this region, cos theta is greater than -1/2. Or maybe if I were to make another graph, it's going to look like this. This is pi. This is pi over 2. This is -pi over 2, and this is -pi. Okay. Now I want it to be greater than -1/2, and -1/2 is somewhere over here. So, somewhere over here, which will give us a value of -1/2 at the second quadrant. Should be pi minus pi over 3, right? Should be pi minus pi over 3, which is 2 pi over 3. So this should be 2 pi over 3, and this should likewise be -2 pi over 3, and it should be greater than that. So it means that our favorable area is this, where it is greater than -1/2. And clearly this red area also takes into account the blue area. In fact, the common intersection of red and blue is just blue. That's why the answer is just option D. Yeah, makes sense. Let's talk about the next one. This one says that a polar function is given by r is equal to -1 plus sine theta, and as theta increases in 0 to pi/2, which are the following is true about the points on the graph of r. Okay, it's easy, because from 0 to pi/2 we just have to find the behavior of sine. From 0 to pi/2, the sine function behaves like this. It just keeps on increasing, right? Okay. The value of r is -1 plus sine theta, or we can say it's sine theta minus 1. Since the value of r sine theta keeps increasing, So can we say that initially the value was, let's say, -1, then it might have become -1/2, then might have become, or maybe I'll put that in decimal, -0.5, then -0.4, then -0.2, then -0.1, because this value keeps increasing in the positive direction and becomes a maximum of 1 at sine pi over 2, because sine pi over 2 is just, and when sine pi over 2 is just 1, and 1 minus 1 is 0, and eventually it becomes 0. So they're asking that what is this pattern? What is happening over here? Let's read the question. Let's read the options. The points on the graph are above the x-axis? No way. Because if they are above the x-axis and getting closer to the origin, that won't really work, because these are not above the x-axis. Here the value of r is negative. It has to be below the x-axis. So above and above are just ruled out. Points are below the x-axis and getting closer to the origin. Points are below the x-axis and getting further from the origin. Obviously, the points are eventually getting towards the origin, closer to the origin. So the answer is option C. This was a little bit tricky, but I hope this makes sense. Temperature in degrees Celsius in a city on a particular day is modeled by this function, rational function, where t is measured in number of hours from 12 p.m. where t can be from 2 to 9. Based on the model, how many hours did it take for the temperature to increase from 0 to 5? Okay, so I think what we need to find is, when is the temperature 0 and when is the temperature 5 degrees Celsius. Once we have a T1 here, once we have a T2 here, they are looking for the value of T2 minus T1, which we can just answer. So give me 1 second, let me pull this graph. So I just used a calculator and plugged this in. First solved for TT is equal to TT is equal to 0. So I got the answer as okay. What is the value of 0, by the way? We have to be a little bit careful here. They want the temperature, they want the number of hours for the temperature to increase from 0 to 5. So when I plug this into the calculator and solve for T is equal to 0, I'm getting the value of the temperature T1 as 5.42. This is the value of T1. And when I plug this into the calculator, that this expression is equal to 5, so the corresponding value of time which I'm getting is 7.70. So if I subtract these two, I get somewhere around 2.3, which is obviously option number D as the final answer. So this one says, this is based on regression. This one says that there's a table that presents the values of function and selected values of x. An exponential regression of ab raised to x is used to model this. We have to find the value of f of 1.5 predicted by the exponential function model. So you have to use your calculator. This is all calculator enabled. You have to use the regression model of the calculator, plug these in as the values in the table, and then eventually find the value of the regression model. I have done that already, and when I did this, I'm getting the value of A as 24.7163 and the value of B as 1.52006 with the value of R square as 0.9934. So the function which we have is A times, which is 24.7163, B raised to, which is 1.52006 raised to x. And since they need the value of f of 1.5, all we need to do is replace x with 1.5. So this will become 24.7163. This is 1.52006 and this is raised to 1.5. So this is approximately coming as 46.77, which is nothing but option number A. Yeah, hope this one makes sense. The next one we have question number 22. Again, it's just something which is based on the trigonometry. It says that the number of minutes of daylight per day for a certain city can be modeled by this particular function, where t is the day of the year from 1 to 365. Which of the following best describes the behavior of dt on day 150? Okay. The number of minutes of daylight per day is increasing at a decreasing rate. The number of minutes of daylight per day is increasing at a decreasing rate. The number of minutes of daylight per day is increasing at an increasing rate, and then decreasing at an increasing rate. So first off, we need to find whether the number of the daylight minutes, the number of minutes of daylight at 150, is that increasing or decreasing? That's our first aim. So let's find the value of d of 149, d of 150, and d of 151. Over here, d of 149 is coming as 876.6223. d of 150 is coming as 877.6626, and the d of 151 is coming as 150 is this 151 is 878.6589. Clearly the value of d is increasing, right? The value of d is increasing, which means that it is increasing, not decreasing. Now, to find whether that's rate is increasing or decreasing, we find the difference of the consecutive terms. So first we find the difference of 150 minus 149, and this value comes out as 1.0403. And then we find the difference between 151 and 150, and this value approximately comes out as 0.9962. So obviously this value, this difference is decreasing, and if this difference is decreasing, which means that the rate is also decreasing. Consecutive difference is the rate, just gives us the rate at which it is happening. So since the difference is decreasing, the function is although increasing because the y values are increasing, but at a decreasing rate. So it should be option number A over here. That's the final answer. Hope that makes sense. Let's talk about the next one. We have over here the value of the function f is given by the function gx is given by sin x minus cos x, and has a period of 2 pi. In order to define the inverse function g, which of the following specifies a restricted domain of g, provided a rationale and provides a rationale for why g is invertible on that domain. So we have to keep in mind that for any function to be inverse, it should be a 1-1 function. Okay. Now for sin x minus cos x, I want this to be a 1-1 function, and it has a period of 2 pi. In order to be the inverse, then which of the following specifies a restricted domain for g, okay, and provides a rationale as to why g is invertible in that domain. 0 to pi, because all possible values of g occur without repeating on the interval. So we have to make sure that it doesn't repeat itself, We have to make sure that if fx1 and fx2 are getting equal, then that should only happen when x1 and x2 are equal, because that is the condition for a 1-1 function. Okay. All right. Now, since the graphical calculator is allowed, I'm going to graph sin x minus cos x. All right, so I have the graph of both the functions ready. This is not required, by the way, since we are not solving it algebraically. So this is the graph of the option A when, I have the function sin x minus cos x, which is between 0 and pi interval. It looks like this. And the other one is like this. So the other one is going to look like this over here. I'm just going to place it here for the moment, where this is sin x minus cos x, which is negative pi over 4 to 3 pi over 4. Now remember, they want that to have a restricted domain so that the inverse exists, and inverse exists only when it falls and when it passes the horizontal line test. And clearly for this function, it is not passing the horizontal line test, because the horizontal line is intersecting, if I draw at this point, it is intersecting at 2 distinct points. So 0 to pi will not work. So 0 to pi is just ignored. Now it's either B or D, because here you can clearly see that any horizontal line is intersecting the function only at one point. I'm just going to find out which one is that. So okay, now if you read option B, it says that it is negative pi over 4 to 3 pi over 4 because all the possible values of G occur without repeating in this interval. That's option number 1, occur without repeating. Okay, all right. And because the length of this interval is half of the period, that doesn't really make any sense, right? Option D doesn't make any sense. So it has to be option B, because all the possible values of G occur without repeating on this interval. That's what we want. We don't want the Y values to be repeated. So the answer for this question would be option number B over here. Hope that makes sense. And the last question which we have over here is a theme park thrill ride involves a tower and a carriage that rapidly moves passengers up and down along a vertical axis as shown in the figure. The carriage is lifted to the top of the tower. Okay. Yeah, it's lifted to the top of the tower and then released to move down the tower, and the ride involves 10 controlled bounces from the highest point to the lowest point and back to the highest point over here. A point X is located at the bottom of the carriage right here. The height X above the ground in feet can be modeled by the periodic function h. At time t equal to 0, X is at the highest point of 120 feet. The lowest point of X is at 20 feet. The next time X is at its highest point is 8 seconds, which is at the end of the first bounce. So which of the following represents h? So in a crux, in a nutshell, we know that the maximum height is 120, which is at t equal to 0, and the minimum height is 20. Based on these two, which are the options which we can perhaps eliminate? Can it be this? Okay, actually we cannot eliminate any of the option, as a matter of fact, because this 50 and 70 is same for all the options, which means that the maximum value will be 120 and the minimum value will still be 20 over here. So both of them work, and at t equal to 0, okay, yes, what we can do is now we can find that at t equal to 0, which one is giving 120. If we put t as 0 over in the sign, it will just become 0. And the height will come as 70, which is not correct because it should be 120. So A and C are rejected by this logic. Now, whether that's B or whether that's D, the only difference is the pi over 4 and pi over 8 thing. And that's where the other information comes in, that the next time X is at the highest point is at t equal to 8, which means that if we put t equal to 0, it shows 120 feet. Now, right at the next time when we are expecting it to have a maximum, that is t equal to 8, which means that its time period is 8 seconds. Obviously, it makes 100% sense because it is maximum here at t equal to 0. Then it takes a ride like this, and then it is maximum once again right at this point, which is the maximum. And this happens after 8 seconds. So 8 is the time period, which means that if you want to write the equation, I'm going to write it as 50 cos of bt plus 70, where the value of b is going to be 2 pi over the time period, where the time period is 8. So the value of b comes out as pi over 4, which is if we sub in over here, this will look like 50 cos pi over 4t plus 70, and this is the final answer, which is option B. I hope that makes sense. This was the last multiple choice questions in the sample paper. Please let me know if you have any questions or any of the step doesn't make any sense in the comment section. I'll try to answer as soon as possible.